Welcome one and all to the video focusing on coterminal trig functions, which is where you will learn to identify the values of the 6 trig functions of coterminal special angles. So there will be many multiple trig topics that will be incorporated into this one video. So in order to get started, let's start reviewing. First thing we'll review is coterminal angles. The big thing is where two angles measured by the difference of a multiple of 360. So an example is where 50 degrees and 410 degrees differ by a full rotation. Next thing we'll review is the reference angle, which is a positive acute angle. And I cannot stress how important it is to identify that, because a reference angle will always be between 0 and 90 degrees, and it is made by the terminal side of an angle and the x-axis. Now, depending on which quadrant you are in, will determine what the reference angle will be and which formula you use to get to that reference angle. So if it's in quadrant 1, well, you can just go ahead and say that that angle is specifically equal to the reference angle itself. If it's in quadrant 2, you take 180 and subtract it by the angle given to you. If it's in the third quadrant, you take the angle given to you this time and subtract 180 from it to get the reference angle. And if it's in the fourth quadrant, you do 360 minus the given angle. Again, you know you did this correctly if your final reference angle is between 0 and 90 degrees, and it has to be positive. Here's a recap on the 6 trig functions. Again, we use the values of x, y, and r because most of these problems will be on the coordinate graph. And because we're focusing on special angles, here's the special right triangles for each type of problem. So 30, 60, 90 establishes it when the sides are lengths of 1 square root of 3 and 2. 45, 45, 90 has it in 1 square root of 2. So please take note of the special right triangles. Here's the chart that goes with it. So if you needed to find what the cosecant of 45 degrees is, then you can clearly say that it is the square root of 2. This is where I will say is going to be very important to establish and identify what your final answer will be, because depending on which quadrant you're in will determine the sign of the final answer, whether the final answer is positive or whether it's negative. So I have it to you in chart form, and here it is on the graphic form, where the acronym A Smart Trig Class should help you remember, depending on which quadrant you're in, which trig functions are positive. So A is where all are positive in quadrant 1. Quadrant 2, it's only sine and its reciprocal of cosecant. Tangent is positive in quadrant 3 with its reciprocal of cotangent, which is the trig. And the last one is class, which is cosine and its reciprocal of secant. So here are the 4 examples. I laid out the directions on the top, where you will learn how to find the value of trig functions given an angle by following this route. If you think you have a good handle on it, go ahead and pause the video and try it on your own, and when you're ready to check your answer, go ahead and resume it. So let's get started. First thing is we have the sine of 585 degrees. We know that it is beyond 360, so what we want to do is we want to subtract 360 from it in order to find the coterminal angle between 0 and 360. So our answer comes out to be 225 degrees, and we know that's in the third quadrant. Now, if it's in the third quadrant, then we can take this coterminal angle and use it to find the reference angle. So we take 225, subtract 180 from it, and we get 45 degrees. Now, because we established that it is a 45 degree angle, we can go ahead and say and identify using the chart what the sine of 445 degrees would be, and that is going to be the square root of 2, square root of 2 over 2. However, it is negative square root of 2 over 2. The reason being is because we are in the third quadrant, and it's sine. The trig function is sine. Sine is only positive when it is in the first quadrant or the second quadrant. If it's in the other two, then it has to be negative. So our final answer is negative square root of 2 over 2. Now let's go to the next example, secant of negative 210 degrees. Now because it's below 0, we want to add 360 to it to get it to be positive. So we add 360 to the negative 210, we get 150 degrees, which we know is in the second quadrant. So because it's in the second quadrant, we can use the reference angle formula where we take 180 and subtract 150 from it to get 30 degrees. Now if it's 30 degrees and we're dealing with the secant function, we can go ahead and use the chart, or you can go ahead and graph it yourself and identify what the ratio is by plugging in the values of the sides that correspond with the angles, and you get 2 square root of 3 over 3. But again, our final answer for this one is negative because secant is the reciprocal of cosine, and cosine is only positive in the first quadrant or in the fourth quadrant. And because we're in the second quadrant, we have to clearly establish that our final answer is negative. So it's negative 2 square root of 3 over 3. Now we're going to go a little bit quicker on these examples. So cosine of 1020, you subtract 360 from it multiple times, twice in fact, and you get 300 degrees, which is in the fourth quadrant. To find the reference angle, we take 360 and subtract 300 from it, so our reference angle is 60 degrees. And our main trig function is cosine, so cosine of 60 degrees will equal 1 over 2, and apologies again, this one is going to be positive because it's cosine in the fourth quadrant, which is when it is positive, other than the first quadrant. Last one is cotangent of negative 690. Here we add 360 2 times until we get to 30 degrees. Now, because it's in the first quadrant, we don't need to use any formula. Our 30-degree coterminal angle is also going to be our reference angle. And because it is our reference angle, we can go ahead and just establish what the cotangent of 30 degrees is, because that was the original function for that problem. So the cotangent of 30 degrees, if we're using that chart or by graphing it, we get the square root of 3. And it will be positive because every trig function is positive in the first quadrant. So this last example actually happened to be the easiest one. So don't assume that all your problems are difficult as you go further along. And that is the end to this video.